Okay, in question 7 we start out with x squared minus 3 times e to the x. So you need to recognise what kind of thing this is to use the correct rule for differentiating it to get dy by dx. And then you've got to differentiate again to get d2y by dx squared. Life will begin to get a little bit more complicated, so don't worry if you get several terms in d2y by dx squared. It will simplify a little, but just keep plugging away and don't do any simplification that you're not confident with. In b.e1 we've got to find the x-coordinate of each of the stationary points on the curve. Now stationary points, you'll remember from core 1 and core 2 and core 3, means that a certain thing is going to equal 0. And then, if you look at when you look at that particular thing, you'll have more than one term here, and what you'll need to do is spot a common factor. So you're going to end up with a bracket with something else in front of it, something in the bracket equaling 0, and each of these things could equal 0. So you're going to have two possibilities. Maybe the thing outside the brackets could equal 0, maybe the thing inside the brackets could equal 0. See if those possibilities work, and you may have more than one x value that does work. It implies that there may be more than one stationary point. So your x values will give you 4 points. And then we've got to determine the nature of the stationary points, so you take your x values, substitute them into the second derivative, and depending on the kind of answers you get, interpret and describe the stationary points.